Welcome. Today we are diving deep into the invisible tech that powers the apps you probably use every single day. You know, from ride sharing to getting your food delivered, we're talking about the science of turning our physical world into digital data. Let's get right into it. So let's start with a question I'm sure you've asked yourself while waiting hungrily for a delivery. How in the world does that app know? How does it figure out the perfect route, predict the traffic, and then give you a countdown that is, let's be honest, scarily accurate most of the time?
Well, the short answer is geospatial data. It's the secret sauce, really. It's this invisible engine humming along behind the scenes of our location-aware world. And today we're going to pull back the curtain and see exactly what that means and how it all works.
All right, first things first, we have to get a handle on the core concept here. What is this data that has a sense of place?
At its heart, it's actually pretty simple. Geospatial data is just any piece of information that's tied to a specific location here on Earth. I mean, sure, think latitude and longitude, but it's also way more than that. It can be the boundary of a city park, the winding path of a river, or the specific area a restaurant will deliver to. It's the where for any piece of data you can imagine.
Now, this data comes in a few different flavors. A point is exactly what it sounds like, a single spot. Think your phone's current GPS location. A polyline just connects a bunch of points to make a line, like a road or a delivery route. A polygon is a closed shape, like the borders of a neighborhood. Then you get raster data. This is basically a grid of pixels. A satellite photo is a perfect example. It's awesome for things that cover an area continuously, like temperature. And finally, vector data uses those precise points and lines to draw clean features, like city boundaries on a map.
Okay, so to manage all this location-based info, we use something called a Geographic Information System, or GIS. And honestly, the best way to think about it is to picture a giant spreadsheet. But, and this is the cool part, every single row in that spreadsheet also has a physical address somewhere on the globe. It's like a spreadsheet that actually understands where.
And of course, there's a whole world of tools out there to do this kind of work. You've got amazing open source options like QGIS, the big enterprise systems like ArcGIS, and then you have the cloud-based powerhouses like Google Earth Engine and the database tools we're about to dive into.
So, while there are a ton of tools, we're going to zoom in on a powerhouse trio that you'll pretty much find at the heart of any modern geospatial system.
Our first tool is PostGIS. Now, this isn't some program you download and run by itself. Nope, it's a super powerful extension that gives a normal database actual geographic superpowers.
So what it does is it bolts right onto a PostgreSQL database and suddenly lets that database understand geography. All of a sudden, your database can answer questions about distance, it can figure out if a location is inside a specific boundary, and it can do all the heavy lifting for mapping out routes.
And here's where the magic happens. A developer doesn't have to write a bunch of complicated math. They can just write a query that basically asks a simple question like, hey, find the 3 restaurants that are closest to this exact spot in Mumbai. PostGIS handles all the complex geometry in the background. It's an absolute game changer. Okay, next up is a really brilliant tool that came out of Uber called H3. The whole idea here is to stop thinking about messy, infinite points on a map and instead to give us a perfectly neat and tidy grid that covers the entire planet.
And here's why it's so special. H3 covers the whole world in a grid of hexagons, kind of like a global honeycomb. So why hexagons? Well, unlike squares, the center of a hexagon is about the same distance to all of its neighbors. It's a simple geometric fact, but it makes it incredibly fast to find all the cells next to you. And that is perfect for things like surge pricing, figuring out where you need more drivers, or efficiently assigning deliveries when you're dealing with a massive scale.
So in practice, using H3 is this simple. You take a normal latitude and longitude, and you just ask the system, what's the unique ID for the hexagon that this spot falls into? Every single location on Earth can be snapped to one of these cells, which makes searching and analyzing huge amounts of data incredibly fast.
All right, our third and final tool in this trio is BigQuery GIS. This is basically Google's answer to running enormous analytical jobs on geospatial data, all without ever having to think about managing a server.
The big wins here are speed and simplicity, but for analytics, so while PostGIS is amazing for live, quick lookups, BigQuery is built to chew through massive historical datasets. It's serverless, which means you just load your data and start asking huge questions. That makes it absolutely perfect for building BI dashboards and spotting those big picture patterns.
And just like with PostGIS, a really complex analytical job becomes a simple question. An analyst can write a query that pretty much just asks, hey, go through our entire database of stores and show me every single one that's within a 5-kilometer circle of this point. And it just does it.
So we've got these 3 amazing tools, but how do they actually play together in a real system? Let's zoom out for a second and follow the data on its journey, all the way from your phone to a final decision being made. Okay, so here's a pretty typical flow. First, you've got location data streaming in from millions of phones. That raw data then gets processed and indexed using Uber's H3 system to snap it onto that neat global grid. From there, it gets stored in a database like PostGIS for those really fast lookups, and it also gets sent over to BigQuery for the big analytical questions. And the final output? Well, that's what you see on your screen. An ETA, a heat map showing where drivers are, or that perfectly optimized route for your delivery.
And the impact of this stuff is just, it's everywhere. It's not just about getting a taxi or a pizza anymore. Telecom companies use this to map out their signal coverage. Health officials use it to track hotspots for a disease. Retailers are analyzing customer data to figure out the perfect spot for their next door. Even emergency services use this stuff to assess damage after a natural disaster. The applications are just massive.
So where is all this headed? Well, this is a field that is growing like crazy, but it definitely has its own unique set of challenges, which of course means there are some incredible career opportunities opening up.
The really big problems that engineers are tackling right now are things like making sure calculations are perfectly precise, because even a tiny error can have huge consequences. They're figuring out how to manage just unbelievable amounts of location data, how to visualize it all so it makes sense, and, this is a big one, how to do all of it in real time while being super respectful of user privacy.
All those challenges create a huge demand for people with these skills. You could be a GIS engineer building the core mapping systems, or a geospatial analyst using tools like BigQuery to uncover insights. You could be a data engineer building the pipelines with H3, or even a machine learning engineer teaching an AI to understand maps and predict traffic. The career potential here is just enormous.
So I'll leave you with a final thought to chew on. We've already mapped our roads, our cities, and our delivery zones with tech that's just getting faster and more powerful by the day. As more and more of our physical world gets translated into digital data, the really big question is, what are we going to choose to map next?